The goal of this project was to design a financially feasible rooftop rainwater collection and monitoring system for dairy operations that would supplement city water use. Accompanying the rainwater harvesting system is a system of tools to help farmers implement and monitor their unique system. Having clean and available water for dairy cows is necessary for milk production. Milk is about 87% water, so for cows to make milk at a consistent rate, they need 50 gallons or more of water each day. Since most dairy operations in Kentucky have about 100 cows, farmers spend over $1,500 a month on hydrating their cows. This project aims to save farmers 10 to 20% on overall water costs through allowing customizable design, cost share suggestions, and financial projections.
For our system design, we have separated it into two major components, the collection system and the supply system. The collection system starts at the gutters and goes through the downspouts, the gutter diverter, through the sedimentation UV filters, and into the cistern. Testing the filters would include collecting samples of water from before and after running through the filters and sending them off for testing. This test would just ensure that the filters clean the water as well as we need them to. To test the gutter diverter and connected linear solenoid, we would need to attach one of the rain sensors to roughly 95% of the height of a catch bucket. Basically, once that sensor detects water, the solenoid would push the lever on the gutter diverter to the other side, which would indicate that water is now being diverted away from our system as to prevent overflow into the cistern. The supply system starts at the cistern and goes back through the pump, through the flow meter into the trough. Testing the system requires a variety of components. Both moisture sensors within the trough, as well as the low moisture sensor within the cistern, would be utilized to test for the pump to be turned on or off. Whenever there is enough water in the cistern but not enough water in the trough, the pump would be triggered to turn on. This also leads to a second test for safety. Whenever the pump is on, we have to make sure that the flow meter detects water. If not, the flow meter should automatically shut off the system and send some sort of alert to the farmer. The majority of these components are controlled utilizing a PLC module, which uses ladder logic. Marshall will explain the programming logic that we utilized for this system design.
The control system is designed to control the whole system and tell the system what to do and when. The goal of the control system is to allow water to remain in the storage tank for a minimal amount of time to minimize the opportunity for bacteria growth. It utilizes the Click PLC module, which communicates with the rain cisterns and the flow meter to determine when and where to move water. Whenever available, water in tank will be pumped out for use. This also maximizes the amount of water that can be harvested and used over time. The only time the system will be unavailable to collect water is when the tank and drinking trough are both full. For this scenario, the controls will activate a diversion system to direct the water away from the cistern and out somewhere wherever the farmer will want. The logic diagrams below will show how the PLC works with the decision it makes in relation to the need of water in the trough and the collection of the rainwater. For financial projections, there is a rainwater harvesting design Excel calculator that takes inputs from the user in relation to their specific dairy to give individuals sizing recommendations and cost projections. The investment required to build the rainwater harvesting system varies per operation, but is estimated to be between $5,000 and $10,000. The design will be able to save dairy operators around 14% of overall water costs for their operation.
There are many cost share programs in the state of Kentucky that are available to help farmers implement sustainable practices. These range from providing funds for simple water diversion systems to covering 90% of overall system implementation, depending on a variety of factors. In some cases, cost share programs can be combined, but regardless of the program a farmer is selected for, the payback period will decrease and financial feasibility will increase. The Rainwater Harvesting Design Calculator accounts for potential savings due to cost share, and a detailed description of the cost share programs included can be found in the written report under Appendix C.
The majority of our future work consists of testing our system, which Cynthia went into in more detail than I will. Basically, we just wanted to make sure that our code and all of the different components ran correctly under all of the different scenarios that our system might encounter. For both testing and demonstration purposes, we designed a small roof and gutter structure which we could use to attach our system to and test the different components working together as a whole. So constructing this structure would be one of the main parts of our future work that we would have to do. Another big thing that we put into this category was creating the online interface. We did not get to do this semester because it required a PLC with Ethernet capabilities and we just did not have the budget for this. So one of the biggest goals for any future work in this project would be to set up that online interface for external monitoring of our system. Lastly, the gutter downspout diverter needed some modifications to be able to run smoothly with our system. As purchased, it was a very high friction system and took a lot of force to move the handle and divert the water between the two downspouts. In its unmodified stage, our solenoid did not exert enough force to move this handle. To fix this issue, we've recommended adding some low friction washers into the gutter diverter. This hopefully would reduce the force required to turn the handle, and the solenoid would be able to reliably move that system back and forth. So that is the rainwater harvesting for dairy operations project. Let us know if you have any questions.